Hello everyone. Um, Welcome to the class real-time systems. So far we have discussed about the introduction and the general purpose computer and also a single chip microprocessor and microcomputer, process related interfaces, and the specialized processors. So these are the things which we are discussed in the previous topics. Now in this topic we are going to discuss about the data transfer techniques. So what is the data transfer techniques? Yeah, characteristics of the most interface devices is that they operate synchronously with respect to the computer and the much lower speed. Okay, so the direct control of this interface device, which is called the programmed transfer, which involves the use of the CPU and that provides the flexibility but inefficient due to the difference in the operating speed with the CPU and also multiple devices. The alternative approach, which is the nothing but a direct memory access. So the transfer which is required set up using the program controller, but the data transfer which takes place directly between the device and the memory without disturbing the operations of CPU. So with the reductions in the cost of ICs and the microprocessor, the detailed control of the input-output operations is being transferred to input-output processor, which provides the buffer entry. Okay, so the example, the input-output processor can be used to control the scanning of the number of analog input channels, only requiring the many computer times which it has collected the data from all the channels. The major problem in the data transferring is nothing but the timing. Okay, so it may thought that the under programmed transfer, the computer can read and write at any time to the devices, that it can be make an unconditional transfer. It applies to the some of the situations like on switches, indicator, the lights, the DACs, etc., which is always ready to receive the data. However, if the device is not the device like on the printer that are not fast enough, but it cannot be miss any the data to be printed, so the unconditional transfer cannot be used. So the computer must be sure that the device is ready to accept the next item of the data. Hence, either the timing loops to synchronize a computer to the external devices or the unconditional transfer that has to be used. Okay. Now, the one of the concept which is used here is nothing but the conditional transfer, which is nothing but a pooling concept. So, in that pooling concept, the simple examples of conditional transfer which is shown in the figure. So, here if you can see in this the flow chart, it will check the device status whether it is ready or not. So if it is ready, transfer the data. Okay, transfer the data to the device, or otherwise again it will check for the data. So in this, if you can see here, in many of the times it performs only the checking the device is ready or not. Only the less number of time it performing the device transfer, I mean the data transfer. Okay, so one of the example which is given here is, assume that the data is being transferred to the printer, which operates at the 40 character per second. The computer receives the data once every 25 milliseconds. So the three instructions which is involved in performing the test will take approximately 5 microseconds. Thus, the conditional test will be carried out the 5000 times for each character transmitted. So the computer spends 99.98% of its time checking so to see if the device is ready, and only the 0.02% of the time doing the useful work, which is inefficient. So that's why we are going for the another thing. In the another thing, if you can see in this flow chart, it checks for the device status whether it is ready or not. If it is ready, transfer the data, or otherwise it's continue the processing. So whatever the processing which is performing earlier, it will go to the particular work and it perform the operations. Okay. A software timing loop that can be used as an alternative to a status line on the interface. For example, the delay can be created by loading the values to the register and repeatedly decrementing the registers until it becomes 0. Okay, so one of the programming which is given LB 25, that is loading the register B with a time delay. So the time delay here given is 25. So the 25 is loaded into the register B, and so the looping, one of the looping concept which is used, the looping is decrement B. So here we are decrementing the B. Once if it is, the delay is reduced, only after that the delay will be decreased. And then ZR NZ. If it is a non-zero, jump R. Okay, jump the repeated. Okay, jump to the locations which is on repeat, jump repeat if it is non-zero to the loop. Okay, and the alternative arrangement for the conditional transfer allows the computation to continue until doing the useful work, which is shown in the figure. Okay, here it will be check the status. If the device is ready, it will transfer is made, or otherwise the computer continues its work and checks the at the later time. Hence, the inefficiency of waiting is avoided here. Okay, but the job of arrangement software to check the device status, which is added here. So the next concept which is used here is interrupt. So interrupt is nothing but a mechanism by which the flow of programs can be temporarily stopped to allow the special piece of the software and interrupt service routine. So interrupt handler to run. So in this diagram, if you can see the dot dot dot, which is represented as an instruction in a program. Okay, so the program which is executing the instruction at this particular time, if the interrupt is arised, it will stop the executions in this particular moment and it is jumped to the interrupt service routine. It jumped to the interrupts, so wants to perform, it is requested. Okay, so the interrupt service routine, once if it is done, and then again it will return back to the interrupts where exactly it is the program is interrupted, in that place it will be written and it will keep on executing the other programs, other instructions which is there in the program. Okay, when this routine has finished, the program which is temporarily suspended is resumed. Okay, so the interrupts are essential for the correct operations of most real-time computer system. Additionally, they are used for the real-time clock, alarm inputs and manual override, the hardware failure indications and debugging aids, and operating system and power failure warnings. So like this, how the interrupt will be, for these reasons the interrupt will be raised. Okay, and saving and restoring the register. Okay, saving and restoring the register. So why it is required saving and restoring? Because whenever the interrupt is occur, it's immediately jump to the interrupt service routine to execute the interrupt service routine. So that time whatever the current status of the current execution program, that need to be stored. Okay, so for that we need a storing, and whenever it is written back to the same program after executing the interrupt service routine, then again need to restore the data. So that's why we need a saving and restoring register concept in this. Okay, since an interrupt can occur at any point in the program, so the precautions have to be taken to prevent the information which is temporarily in the CPU register from being overwritten. Okay, all the CPUs are automatically save the content of the program counter which is on written. Okay, else the returns to the program where interrupts was made will not be possible. So some CPUs, however, do not to save all the register. There are methods or to follow. One is the save the content of the register in the specified area of the memory. Second is store the registers on the memory stack. This is simple and also it is widely used method for permits the multi-level interrupts and the major disadvantages of the danger of stack overflow. Okay, use of an auxiliary set of register. Some processor have two set of the main registers and an interrupt service routine that can be switched to an alternative set. If only two sets are provided, the multi-level interrupts cannot be handled. And the automatic storage of working register is an inefficient method if all the registers are used. So unless the response time is critical, it is good engineering practice to save all the registers. So this ensures the values in the register have not been changed due to modification. So this machine status that can be stored on exit of the interrupt routine. So one of the example which is given for the interrupt service routine. So it is calling and saving and call, returning back to the program and EI, and it is returning. Interrupt input mechanisms. Whenever the interrupt is occur, what will happens? Okay, so a simple form of the interrupt input which is shown in the figure. The interrupts fetch, decode, executes and instruction which will be completed. Once if it is completed, then it will check whether the IRQs are active or not. If it is yes, then interrupt service routine it checks If it is no, then again it's go to the previous instruction, I mean the next instruction fetch, decode and executes. Okay. Once the instructions are completed, it will check whether IRQs are active or not. If it is no, then the clock cycles which will be sent and the other instructions which will be executing. So like this how the interrupt service mechanisms will perform. Okay, so in between each instruction, the GPU checks the IRQ line if active, an interrupt is present or not. If the interrupt service routine is entered, if not active, the next instruction is fetched and the cycle repeats. Note that the instructions involves more than one CPU clock cycles and the interrupt is checked in between the instructions, and hence the interrupt signals may have to be latched. And a common arrangement which is the two interrupt lines which is shown here, the IRQ and also a NMI, both are the low level interrupts, and one of the line is IRQ that can be enabled and disabled using the software. Hence the computer can run in the mode in which the external events cannot disturb the process. A second interrupt line which is provided, this interrupts cannot be turned off by the software and hence it is said to be a non-maskable interrupt. Example, the power failure deductions and all. So to connect the multiple interrupts, use kits. And interrupt response mechanism, how the interrupt will be responded. So the CPU may respond to an interrupt in the variety of ways. One is the transfer control to the specified address, usually in the form of call instruction, and load the program counter with a new value from the specified registers or memory location and execute a call instruction but one address specified supplied from the external systems. Use and output signals and interrupt acknowledge to fetch an instructions from an external devices. Okay. So in this there are four methods are there. The first two method which is related to the software bias and second two which is related to the hardware biased. So the method 2, interrupt vector or the interrupt response vector, it is nothing but an interrupt service routine is saved in the specific memory location. The next is hardware vector interrupt. So the methods, the third and fourth which is related to the hardware vector interrupts, that identifies the external devices has generated an interrupt or not. So they are requires a mechanism to attribute between the possible sources of the inputs interrupts to prevent more than one interrupt activate the IRQ at one time. Okay. So the process of attributions involves the assigning the priorities to the various interrupts. A frequency used arrangements in the delay chain in which the acknowledged signal is propagated through the device until it is blocked by the interrupting devices. For example, in the next slide. Okay. So the each unit has IEI, interrupt enable in. That is one of the pin, and IEO, it's an interrupt enable out. So both are assumed to have an active high signal. So this device priority is determined by its position. So this is one of the example which is given. And interrupt response vector. So the interrupt response vectors is a above system that can take a variety of forms. One is it may be an instruction or the address of the interrupt service routine or the address of the pointer to on the interrupt service routine, the part of the addresses of the interrupt service routine or a pointer. So the widely which is used here is interrupt device suppliers, the address of one locations in which the pointer to the start of interrupt routine which is stored. And these are the multi-level interrupts. And this is interrupt masking. So like this how it will be performed IRQ. So it will retry on interrupt, save the register and save the current position and the output new mask registers and enable the interrupts and service the devices and disable the interrupt and restore the previous mask and restore the registers and enable the interrupt and return to the previous program. Okay, so like this how it performs. And then last one is the direct memory access. So in direct memory access there are three methods. One is the burst mode, second one is distributed mode and third one is cycle stealing mode. So the burst mode, which is nothing but the DMA controller takes over the data highways of the computer and look out the CPU for a period of time necessary for the transfer between the fast memory and also a blocking memory that can alter the response time of the real-time systems. Hence, it is not acceptable. So, the distributed mode, the DMA controller that takes the occasional machine cycles for the CPU to transfer the byte of information. So, the loss of mechanism cycle is generally not noticeable. So, in real-time system, it can cause us the delay. And cycle stealing mode, it transfers the data during the cycle when the CPU is not using the databases. The program proceeds as a normal rate. So this is the slowest method, slowest transfer. Okay. So these are the data transfer techniques. What are the techniques which is there in the data transfer? Polling concept and the improved polling method, and also the interrupt and interrupt service mechanism, interrupts input mechanism, interrupt response mechanisms, and also hardware interrupts, multi-level interrupts, and DMA. So these are the things which we discussed in this topic. So these are the references. I hope this video is very helpful for you. We'll meet you in the next video. Thank you all.